Thank you very much to invite me today to present this our work to you. Uh, this paper has collaborated with Dr. Griva and Dr. Kennedy. Both are my members of my dissertation's research committee at George Mason University. By the way, I'm John Leung and a PhD candidate in computational science and informatics at George Mason. And I'm very happy to here to present our paper to you. This is the outline I have prepared for today, and I will go through the item one at a time. We actually like to we want to make cross information domain emotion aware recommendation. The subject of cross-domain information recommendation making isn't new in the field of recommender system. Many research papers have documented the concept, methodology, formulation, and studies of various related issues. Most of the recommender systems in the field are domain-specific. Recommender systems such as Netflix, Cinematch serve the video content delivery domain, while the Amazon recommendations engine lives in the e-commerce domain. Some systems already offer joint recommendation of items in different domains. Still, in general, to make a recommender system in one domain, developer exploit only user preferences on that target domain. Cross-domain recommendation making is an emerging research topic in the field of recommender systems. Researchers must investigate the following critical issue in building cross-domain recommendation system. A, verifying the existence of global correlation of user preferences for items in different domains. B, designing models that exploit users' preferences on a source domain for predicting user preferences on a target domain. And C, developing evaluation techniques appropriate for cross-domain recommendations. We shall examine these three issues in today's presentation. We need emotion label dataset to work with filter algorithms that runs in the deep learning environment. However, no readily available emotion label dataset. Many researchers manually tagged emotion feature for a non-affective label dataset. Such efforts is labor-intensive, expensive, and time-consuming, and may require domain expert involvement, and may not be feasible for many situations. We are interested in tracking 6 basic human emotions as advocated by Paul Ekman's 7 primary human emotions depicted in the diagram on the right. We exclude Ekman's content emotion, and for our affective computing convenience, we add a neutral sentiment to our emotion set, namely neutral happiness, sadness, fear, anger, disgust, and surprise. Many researchers apply facial expression detections and recognitions for classifying basic human emotions. However, we use the text-based contextual method on subjective text to detect and recognize basic human emotion. The table on the left contained an emotion synonyms file that we download from the WorldNet Affect team, comprising the 6 primary human emotion keyword synonyms. Using these synonyms as keyword tags of treats. We extract all the moods records from the Twitter database that match the keyword tag. The number of mood record per emotion class that we retrieve from Twitter database is unbalanced. For example, the middle table containing the happiness keyword tag returned over 138,000 tweets, while the keyword tag surprise returned only 15,000 tweets. The table on the right depicts the complete statistic of return keyword tweets records retrieved from Twitter. We subsample each emotion class with 15,000 records split into 12,000 records for training and 3,000 for testing and validation. We developed a text-based emotion detections and recognition classifier using an asymmetric double-decker butterfly wing bidirectional LSTM to CNN Conv 1D neural network architecture. We defined our model architecture consists of two halves. The block diagram depicts on the top left, showing the first half of the RNN LSTM to CNN Conv 1D architecture, and that text input process by an LSTM architecture before following up data processing by a CNN Conv 1D architecture as depicted in the block diagram on the lower left. The second half of the model is reversing the architecture processing order. Input first, processed by CNN Conv 1D architecture before feeding it to a RNN LSTM architecture. The block diagram in the middle of the bottom row showing the two halves of the architecture combines to feed data into a mixed pooling layer of a CNN for a pooling operation to select the dominant feature in the filter's regional feature map. Next, the data passed into a CNN flattening layer to convert data into a one-dimensional array before feeding data to a fully connected CNN array, CNN layer. The dense layers output will provide a set of nukes equal to the number of classes the architecture aims to classify. Each of the output nukes holds the output distribution value of its class. And the table on the right also show a treat's effective classifier achieve F1 score of 55.6 accuracy in classifying the treat's balanced dataset emotion class. Depicted in the upper row is tagged in action. Tag here stand for the treat effective classifier. We picked the Godfather 1972 movie to illustrate tag in action. We feed the movie overview to tag and get a emotion profile we call MVAX for the film and depicts in the table upper row on the right. With the MVAX affective features probability distribution value, we can describe the Godfather 1972 movie. But before that, let me point out the movie, The Godfather 1972 MVAX show hate stands as a dominant feature, followed by anger, disgust, surprise, sadness, neutral, and close out by joy. If we recite this MVAX in the following way, we can describe the movie as follows. The Godfather 1972 movie is a film full of hate. It is an angry movie. The content is disgusting due to the violent nature of the film. However, the story of the movie is full of surprises, but it's that movie. None can say the film celebrates happiness. So by reciting the MVAX attributes, we describe the movie. We can use the UVAX of a specific user's emotion profile who watched The Godfather 1972 to explain how well the user has enjoyed the movie. Surprisingly, we can leverage the MVAX and UVAX as a sentiment analysis tool in the recommender system. The table in the lower left listed the first few rows of the emotion label movie dataset. We scraped the TMDB database for all movie metadata, particularly the movie overviews. We apply tag to classify the movie's emotion label, MVAX, through the movie overview. We merge the emotion label TMDB dataset with the MovieLens link dataset to make the MovieLens dataset emotion labeled. The table on the right in the bottom row depicts the MovieLens dataset grouping to view the individual user's movie watching history. We sort each user movie watching history by their timestamp in descending order and split each user movie watching history into 20% movie watched and 80% movie to be watched group. We compute each user's emotion profile UVAX by taking the average of all the movies MVAX the user has watched. The lower right table depicts all 610 users UVAX in MLens ML latest small dataset. When we work with multiple dataset within the same or different domain, we usually face the following problem. For example, here the test user ID 414 may not sort of be the same user ID 414 who reside in a different data set. If we can sort of find a user ID in another data set that match up well with user ID 414, so we can say user 414 that match up with another user with different ID in different data set as a disjoint user. So we may like to find the most alike user reside in other data set to join or connect them. The affective aware pseudo association method can do just that. It matches the disjoint user's likeness through the affective index indicator based on the pairwise cosine similarity of the disjoint user's UVAX. Depicted in the table are 4 arrows that point to 4 specific rows. Let me just simply extract that 4 rows into this another table for better viewing. The first row the first row to represent the disjoint user. The first row here, what I meant here is this. We have the test user 414 who will match up well with disjoint user in the ML20M data set. The ID is 125022. Also match up well with the MLens data set ML25M ID 131662. Another sort of a user ID 236165 in MLens ML27M dataset, and also to user 10354 in Amazon dataset the digital music dataset, as well as Amazon dataset toy and games, user ID 97437. So all these users, they are considered as disjoint user. The second row here indicate the number of items the user has consumed. For example, for user 414, he or she have watched 2,698 movies. And for example, for user in the Amazon digital music, that user have listened to 5 musics, or in the toy and games, that user have bought 20 items. The third row indicate the UVAX of the respective users. And the last row indicate the affective index indicator that is computed through cosine similarity. And here is the number that indicate that all these disjoint users are matched up quite well with the test user 414. Here we have showed a sample of Amazon review data set in the, on the left here, that we extract one of the sample record. It's placed in JSON format. Basically, it's a key value pair. In the middle row here, there is an entry review text. So we are utilize this review text, and we feed it to our treats affective classifier to obtain the IVEX, or the item vectors, emotion profile for that particular item. So again, on the table on the right here, show 2 examples for 2 different users, IVEX. The recommended filtering techniques, basically a collaborator filtering technique is the most popular rating-based recommendation filtering techniques. Content-based filtering techniques rely on users' profile generated from users' metadata, including user explicit rating score given to items. The hybrid filtering techniques combines 2 or more filtering techniques. Our goal here is to make cross-domain recommendation using users' UVAX and items' IVAX. And we try to achieve something like this in a collaborative filtering style. User A of MovieLens, like movie X, has a similar UVAX of user B of Amazon. So user A may like Amazon's product and services that B likes. And the table lists 5 review sample of reference ID or user ID 10354 in digital music of Amazon. And we only list 5 out of 20 item for ID 97437 in Amazon toy and games. So for Amazon user ID 10354, here we indicate one of the item out of the 5 is rated highly, a 5. So that can use as a candidate to make recommendation to test user 414 in the MovieLens. Similarly, user ID 97437 earlier indicated that he or she consumed 20 items of the toy and games that marketed by Amazon. Here they rated 3 items rated highly, so all of them can be candidate for recommendation to user 414. In conclusion, we say Amazon, we say the emotion profiles for users and item can be derived through a contextual text-based treats affective classifier on subjective text, such as movie overviews or review made by customer sentiments. By modeling the user's emotion profile UX as the average of all consumed item emotion profile IVEX, it can better capture the user's mood change dynamics. The affective aware pseudo association method can use to pseudo associate connect destroy users or items in different data set that reside in the same or different information domain. Users and item emotion profile can be used to make cross-domain recommendations. I'm happy to answer any question you have.